So here's our topics for tonight. This is what I'm really looking for. I want to try to just do some basic setups with things. I want to show you how to develop a process and then probably even get into a little bit of programming. I know some of you are here because you want to learn about coding. There were a fair bit of you that wanted to know about just different kind of challenges you could run in your classrooms. Maybe that didn't even require coding. Here's just kind of some basic setup. So I highly recommend that we use the online version tonight. But this link right here, this code v5.vex.com, if you have the presentation open, you can just click it. But we use the website the large majority of the time. We do have a standalone software version, but what I've found for us personally in our classes is that it's kind of a pain to keep updated. So we just use the website. We have robotics in our POE class all year long. We don't just do it in one particular unit, we do it all year. So in the first part of the year, probably up to Thanksgiving or so, we're in block coding. We're in block coding pretty heavy. Right after that, toward Christmas break, we start kind of easing into Python, and then by the time we get back from that break, we're really going full throttle with Python. I have two types of kids, and you probably do too. We got the mechanical type, and we got the logical type. The mechanical type, these are my kind of people, right? If it doesn't work, what they do is they make a new piece or they put a new switch in or they put a new motor in. They fix it physically is what they do. Then you got the logical type. And these are the kids that just sit there and it looks like they're doing absolutely nothing. But they're not. What they're doing is they're fixing everything through coding. One thing that's important, I know, like I said, a lot of you know our project lead the way. So just knowing where things are is helpful. So in this code, the V5 interface, you're looking here at just the different sections and what they can do for you. Okay. So like the motor and the motion commands, all that kind of stuff, and just kind of knowing where to find things. I will say most of what we do is in the motion section. We do some with the control, and we do a little bit of sensing, and we do some operators. You really do need to spend some time with that and give the kids just some time to play around. And here's honestly how I do it. I go up to here. There's a site called vr.vex.com. And you can go there. And this was developed during COVID. So there's a lot of free stuff here. Now they do also have like a paid version as well, but there's enough on the free version that your kids can go in there and kind of learn. And it's a virtual bot. Okay, so it's actually pretty cool. So in here, there are some tutorials. There's a learn section. It's actually pretty handy, but here are some things that I might do with my kids. I might go over here and say, all right, kids, I want you to go to a select playground. And you see a lot of these say premium license, but there's a lot down here as well that's free. And it's pretty cool stuff. One of the things I like to do is this wall maze. I'm real big on this one. The kids, a lot of the stuff we do is just making a robot move, right? So maybe we'll open up the wall maze. So what I do, and this could be one of those things where as the kids walk in the room, I have this up on the board and say, all right, I want you to take your robot and I want you to make it land on the letter A. Okay. So let me clean that off. Now the difference here though, the difference between this and the actual coding site is that all the motors and things are already set up for you here. So you know how you go to devices and typical, you don't do that here. They're already kind of set up. So the nice thing is though, we can see, we're gonna drive forward for, I don't know, 200 millimeters. Let's see how that works. And then it looked like we needed to turn, and I'm gonna say turn left. And I'm just gonna go right here and click start and see what it does. Okay, so it drove forward, it turned left. Oh goodness, it's still turning left, right? So now I can say, all right, well, let's stop. Let's go over here. Maybe instead of turning left, Maybe I'm just going to turn, and I can change this, right, to turn left for 90 degrees. Maybe I need to do that. Let's reset it first, and let's hit play. So 200, we turn left. That's pretty good. Now, if I'm looking, that's not quite enough, is it? So I say, all right, well, let's do 215 here. We're going to say turn left for 90. And I think I'll say drive forward for another 215. And then you know what? I think I'll say turn left. Instead of turn right, I can say turn left, right, for 90. Let's reset that and see what we got. So up, over, up, turn left. Good. Now I'll just come back and say, you know what? Let's drive forward for the 215. Okay, let's reset it. Let's hit play again. And there I go. I'm good. Now, as I progress, though, I could come back to the kids and say, all right, instead of just landing on the A, I want you to get to the A within, I don't know, let's say 2.5 seconds. So the kids are like, oh, goodness, I'm going to have to speed this thing up, right? So then we're like, okay, well, it can be, you can speed it up. You just need to figure out how. So they're going to have to look around, aren't they? You're going to have to say, let's try and find things out. There's this velocity, there's a drive velocity. I wonder if I put that up there. I said, you know what? Let's set that to 100. Now let's reset this thing and let's hit play now. And there it was. So the idea here is just kind of an exploration thing. We just kind of want them to discover, right? We want them to kind of see everything that's available to them. You can also, there's a lot of playgrounds here. The art canvas is kind of neat because what I'll do there is I'll say, all right, I want you to just spell your name, or I want you to draw a random shape in a certain color. The shape tracer is kind of a neat one as well. I can say, you know what? I want you to make the plus sign red. Then I want you to hop over here to this octagon and make it green. And I want you to hop over somewhere else. You know, you get the idea. There's a lot of cool stuff you can do with that website. And it also gives you a chance, right, to get in things like attendance and all that administrative stuff. Plus, more importantly, it gives you a chance to kind of go around, walk around your room, check in with your kids and just see how they're doing, building relationships. Here's kind of the process we use with our kids. First, we need to know, all right, what is our robot supposed to do? And then we need to think about what motors and sensors are we going to have to make that happen? And then what operation do we need to do? And then we kind of break it down. For those of you that were robot C people, we used to call it pseudocode. So what we would do with that is we would take the code and we would convert it over to, human language, basically. Here's a sheet, and I put it on slide 19. You can click on this and download it. You can click it there, or you can click it there. This is slide 19. This is just kind of a way for kids to outline how things are going to work. So like up here with I'll just open it up. First, when you click that, it's going to say make a copy. So after you make a copy, then you'll have access to the Google Doc is all it is. But the purpose up here, I need the kids to write it out. Like, what is this robot supposed to do? Okay. So then, all right, what kind of movements do we have? I've found 3 tends to work pretty well for us. If we need more than 3, I just say grab another sheet. Okay. So in the movement, what is supposed to happen? And then I have them come down here and I say, all right, if it requires a motor, what's the number of that motor going to be? And then I'm like, all right, also, let's go down through here. Do we need any specific stuff? Do we need a bump switch? Do we need a limit? Do we need any kind of optical or anything else? Do we need those? And I'll just say, click the checkbox if we need it. And then I'll have them use this bottom label that says sequence and be like, all right, is there a certain order that all this needs to happen in? Because if there is, let's get it listed out here. What I found is this really can kind of accelerate their coding ability. Because a lot of times what kids won't do, they're in their defense, they're just like me. As soon as I see it, I go immediately for the VEX pieces and I just start crafting, right? There's no planning or anything like that. And one of the common things I see a lot, one of the big questions is, and my kids take forever to build anything. When you're doing your first build, sure, it's going to take them a while, right? Because they're learning where everything is, they're learning how things go together. I get that. But one of the big reasons it takes forever is because they don't have a plan. And you're just kind of crafting as they go. And that's a recipe for not finishing many projects, put it that way. So I'll kind of roll back up here now. So step one, this is a little more detailed about it. What's your robot going to need to do? So I just ask them a bunch of questions. I usually use this slide. I'm like, this is what we need to think about. What kind of inputs is it going to have? Does it need push buttons? If we're building a line follower, the function is to follow a line for sure, but what kind of sensors are we going to need to dig up? What kind of sequence are we trying to dig up? So what I'm trying to do is just get them to frame it up, right? What do I need to do to make this happen? Then the next step is we start going in here and we start saying, okay, how do I set this thing up? Do I go to the device managers that we call it now? Set up my motors, set up my sensors, and we need to spend some time with that. That's a kind of an important thing because if they don't set up their motors, those categories we talked about earlier, they're not going to see those. If they don't have any motors set up, there's not going to be a motion section for them. So got to set it up. In step three, we just kind of, what are the actual operations? So what we're trying to do here is just really formulate out what we're making here. I want them to take the English and I want them to put it into code form. I want them to be going back and forth. We don't do much different. We're basically teaching a language class, right? We are. So if we think about it, coding is a foreign language. We have to translate that into a language that we understand. Then we make sure we break down these components. So if the robot's going to lift something, we want to make sure that we start developing, right, the mechanical engineering aspect of it. How are we going to lift it? Are we going to have a claw pick it up? Are we going to use some sort of elevator device? What kind of gear systems are we going to use, right? Are we going to use a rack and pinion? Are we going to use spur gears there's all kinds of options there, right? But we want the kids to think through that. And a lot of the problem here too with VEX builds is your kids don't have a mechanical engineering background, right? A lot of us, there are some of us I know that are dealing with middle school level. Some of us are dealing with high school level. And most of the time, the kids that we get, they haven't had a lot of experience with engineering aspects at all. So then we kind of come out here in step 5 and say, all right, let's convert it over to English. What is supposed to happen? So words we understand. And then finally, we just actually get into the coding aspect of it. So we write the code. Like I said at the beginning, we'll write the code in block. And then there's kind of a translate button, for lack of a better word. And as soon as we click that, we can actually get the Python version of it, or we can get the C++ version of it as well. Which kind of depends on what we're teaching, right? Me personally, I think the value of coding is that we can understand a sequence and we can understand that we are communicating with the robot, right? We are telling the robot what physical components need to move and in what order they need to move. Let's take a look at a little bit of programming. Okay, so all of these programs that I'm about to go through, if you click the picture, there's a link to download it. Okay, so like the first one is printing to the screen. So you can see the code here, but you can also click that and you can download it. Okay, on the codes, what I tried to do, on one side, on the left side, I tried to give you the block version. And on the right side, I tried to give you the Python version. Okay, so that you had it available to you. I'll go ahead and load this one up so you can see what it does. So if you were to download those, you could go here to File and say Open. It's going to ask you if you want to save your current project. Mine are all in my downloads folder. All right, so this is the first code. And what we're trying to do here is we are trying to make it right to the screen. So there are absolutely no motors involved yet. I use this one right off the bat with the kids because it gets them going immediately, right? They can see immediate feedback, and I don't have to worry about the confusion of the devices. I don't have to say, let's hook up a motor. Let's do all that. Trust me, on that first day, just hooking up a brain to their computer, that's going to be all you want to handle that day, probably. I'll go over here to brain, and I'm going to say connect because right now it's disconnected. All right, so I'll click connect and continue. Now there's two options here, and I don't know why it's like that, but I always know, and I always tell the kid, just pick the longer one, please. Okay, so you click that and you click connect, and you notice now the brain up here kind of turns to a teal color. Now what it's saying is we're connected. So I can click download, and I can download that straight to the brain. So I'm going to hit play on that program, and you're going to see there it is. It says, hello, everyone. Welcome to a VEX V5 coding session. And then check out, of course, there's always self-promotion there, right? But all we're doing here is we're just teaching the kids how to communicate with the screen. So on your screen, you should be seeing the code again. If we look at that, it says set pin color to CN on the brain. Now I use certain colors because I knew they were going to show up better for tonight. But you could say, all right, kids, let's set it to red. Okay, so we're going to set this to red. We're setting the cursor to a particular position. So if we were in a Word document or a Google Doc, we're clicking and telling it where the cursor should be. And when it says print, we're going to say type your message right there. What do you want this to say? And then all I've done is I've just changed the pin color a little bit here and there. And then I move the cursor to a different row. But let's look at this section. These are all purple. So that tells me it must be in the purple dot over here, which is looks. Let's look. There's purple. There's that print command. Here's the set cursor. We could also just say go to the next row. Okay. We can clear the row. We can do all kinds of stuff. And then we can actually go down here to draw. And some of this is relatively new. You can actually have it draw rectangles. You can have it draw circles. You can make your pin width bigger. You can set your screen to fill colors. So the other day I had a kid that was he made a little video game on his brain, and he made different flags of different countries, some of the simple ones. And he would pull it up on the screen, and the kids had to identify what country it was. Really simple, but really cool at the same time. So, like I said, this is kind of my first gig with the kids. Just like, hey, let's just see if we can talk to the thing. For all I would want them to do at this point, it's just something like this. Let's just set a pin color and let's just say hello, everybody, or hey, make it say your name, make it write your name. You just keep it simple at first, because we're not trying to go crazy off this first day, right? But just something simple like just write your name. Right over here, this is kind of that translate button here. If I click that, this is going to give me different versions. So right now, because at the bottom, if you look at this screen, it says Python. And if I click over here, it will give me the C++ version. And you're like, oh my gosh, I'm just happy to do block. I get that. But Python and C++ are probably the most common languages outside of Java. Okay, so it's nice for the kids to be able to see this. For those of you that do have kids that do a lot of Java, I don't, but if you do, C++ is going to be a little bit closer to that language. Okay. So all I'm doing at this point, and honestly, I don't do this the first day at all. I'm just happy that we could write our names on the brick. Okay. But as we progress through the year, I'm saying, you know what? Let's go ahead and click that Python button. And let's drag this kind of over here. And let's compare the two. And let's see what kind of things we can pick up here. Let's take a look here at just a basic motor. So what's going to happen when we run this program? What are some variables we can have the students change really quickly? So when I teach this to the kid, I'm going to say, all right, why don't we do this for right now, kids? Let's do a follow along. And then here in a minute, I'm going to give you some stuff. I'm going to change things up a little bit. So here's what we'll do. What we've got here, and this is what I'm doing live in front of them, I'm going to say, what's going to happen? And so I'm going to say, all right, take a look at it. What do you think is going to happen? And I want to give them enough wait time to actually formulate a thought, right? So they're going to say, well, it's going to spin a motor forward and it must be spinning it for 3 seconds and it's going to stop it. So I guess that's what it sounds like. Well, let's try it out. Let's make one together. So I say, let's do file and say new blocks project. Okay. So file and new blocks project. And I'm going to say, let's, before we can get going here, kids, one thing we didn't have to do yesterday, because remember, we just did a straight to the brain thing, right? What we're going to do now is we're saying, all right, we need to put some devices in there. So I'll click add a device. Say now we're supposed to do what, kids? And like, it was supposed to make a motor go for 3 seconds. Oh, okay. So I probably need to set up a motor, don't I? Yeah. So there's a motor. And then I need to know what motor port to choose. Okay. Which on my test over there, I have motors in ports 1, 2, 3, and 4. Okay, so I'm just going to say motor 1. And I'll click done. So now I have a motion tab over here. I'm sorry, do I really need to add anything else though? I'm like, well, you need to add some way to wait. Like, that's a good observation. But with wait, we don't have to do anything with that. We can actually program that in. So I'm going to kind of maximize my screen because remember, they may have a Chromebook, right? So just kind of click that sidebar there. So again, right here, click that, that'll go away. So I'm going to say motion. So I'm going to say spin motor 1 forward. They're going to be like, what did you have? What about if we wanted motor 2? Well, did we set a motor 2 up? No. Okay, so we can't use that yet. Be like, okay, so where do we go for a wait command? And I'll show them the code here. And they're going to be like, oh, it was orange. It's orange, so it must be in the orange area. And then they're going to say, well, events and control are both orange. So they'll click on events and they're like, it's not there. Right. So it must be in the control section. So we'll slide that 1 over and say, all right, let's make it 3. So we're going to spin motor 1 forward for 3 seconds. Then what are we going to do? Well, we got to make it stop. Yeah. So stop and go, they're all in that motion, right? That's a type of motion. So I'll say stop motor 1. And like in your command, you had a stop project. Do we need to put that? Be like, not really, because at this point, this program would do what it's told. But it's good practice to go ahead and put that in there. It's not going to end the world if you don't, but it sure does help things as you get progressive down the road here. And stop is down there at the end. Okay, so I've got a code here now. All right, it's downloaded it now. So now I'm going to press the play button. And you can see that the motor 1 is spinning. It ran its code, it stopped. I'll do it again. 1, 2, 3. Stop. So I am all set. Good to go, right? Let's take a look at something a little more advanced now. So now we're going to add a motor and a switch. Okay, so that first day, and even maybe even the second day, I might just say, all right, let's make a code now where we have a motor 1 and it goes for 3 seconds. And then our motor 2 is going to go for 3 seconds. And then our motor 3 is going to go for, I think you get the idea. But we may just say, let's just make the motors go at this. So that way they get plenty of repetition and practice there. All right, so I'm starting again, motor and a switch. And I'm going to say, all right, kids, let's look at this code. What's going to happen when we run this thing? And I want to give the kids a chance here. Say, let's take a good, honest look at it, because you're always gonna have that one kid that knows it right off the bat, right? They're gonna be like, well, blah 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 blah. And you're like, nobody else got a chance to think, dude. Come on. So what's gonna happen? And they're looking through it. First off, then I'll ask the kids what is actually gonna happen, and they're like, well, it looks like this motor is gonna stay put. It's not gonna move until you press bumper A. So until you press the bumper, it's just going to stay still. That's good. Hey, what about that velocity thing? What's that mean? It looks like you're going to set it to 75%. So this is the time I'm going to ask them, be like, hey, so what does 75% mean? Okay, what is 75%? And why is that significant? Like, I don't know, man. Like, that's fair. It's because default is 50% of motor capacity. So we're going to take this. It says basically we're going to create a bump switch here. So I'll come out here and let's say file and new. Discard that. I need to go over to my devices. I'm going to say let's add a device. I know I had a motor. And then I know that I had a bump switch. Now, these bump switches, they're a little old school. So you have to say, hey, that's a 3-wire. And for some reason, the kids always want to click this 3-wire expander. I'll be frank with you, I've never used one of those ever, never needed to. So I just tell them, go ahead and click the snowflake. Okay, so 3-wire right there. Then it shows up all the old analog stuff and some of the digital stuff. So the old school VEX stuff here. And I'm going to say this is really a bumper. It's a bump switch. And then we need to select, all right, what letter port, because this is a 3-wire deal. Say, hey. Okay, so I've got all the necessary equipment. So let's look back. Okay, so it looks like every time I press A, the motor should turn on. And since I said every time, that means it's in a loop, right? So it's forever loop. Okay, so the kids are going to come over here and they're going to say, all right, a forever loop, that should be in the control section. It is. So let's drag forever. So we're going to say forever. Right now, the motor is going to say stop. Okay, forever. And stop motor 1. And for control, we're going to say wait until. Wait until. And this is good. So right now, I'm still kind of guiding the kids through this. So this right here is still up on the board. I'm kind of letting them cheat right now because we're nowhere near ready, right? We're kind of cheating a little bit. So I'm going to say, all right, wait until what? Well, in real life, we want the bumper, we want the switch to be pressed. So I'm going to say sensing. And I'm looking, there's some sensors here. These look like timers. Here's some motor sensing. That's not it either. But hey, here's a bumper right here. So I'm going to drag that and put that in that hexagon. That's hexagon shape. Goes in there. So wait until bumper A is pressed. And then I can say, you know what? Let's just spin the motor forward. And that needs to just kind of drag in under there. But if you remember, we also put a velocity on that too, didn't we? As you can see right here, it is set motor velocity to 50%. That's default. We said in our original code, hey, let's get that to 75%. We're going to jack up the speed a little bit here. So that's what we'll do. We'll say set motor velocity and change the 50 over to a 75. Because I'm moving over to the device, I'll press play. And then when I hold the B button here, or I guess the A button, motor's running. If I let it go, it stops. Press it, let it go. As long as I have my finger on it, it works just fine. Okay. There are a couple more here. Let's take a look at some sensors. So here's a distance sensor. So this one, we're starting to get a little more high tech with the coding. What we've got here is we've used in this little green hexagon. This is an operator, is what that's called. So in the operator, we're probably doing a less than or a more than, we're doing a less than or greater than, sorry. We're doing some sort of comparison. So if I'm looking at this code, and here we are, we're trying to say, all right, kids, let's look at the code. What does it do? It looks like a distance sensor, going to read in inches. And if it's less than 3, then it's going to do these things. It's going to turn the motor on at 75%, it's going to spin it. If it's greater than 3, the motor's not going to run. That's very good. That's what's going to happen. So let's go through and let's see if we can code it. Okay. So we'll say file and new. And here we are. We're back to our strategy here, though, right? We're saying, okay, I got to go over here and set up my devices. Set those up. Okay. So I'm going to say, all right, well, I had a motor. I had motor 1. And then I had another device, which was a distance sensor. So we'll say distance sensor 12. All right, so I've got this set up. Okay, so if, and we want this to happen all the time, so forever. And this looks like an if then, maybe even an if then else statement, right? Yeah, if the sensor reads, then do this. Elsewise, do this. So it's an if then else. Right here. Okay, if then, so this, let's figure out, let's do the motors first because we're pretty good at that. We'll set the motor velocity. I think we said 75%. And then we'll say spin motor 1 forward. Elsewise, I want you to stop the motor. All right. We can handle that because we've got experience with that. And by this point, they're going to be pretty good with that. The operator, though, that's going to be a doozy first. So we're going to say operator. And right here, there's the less than, right? So we're going to drag that over into this hexagon. And I know the number over here was 3. Okay, but they're like, but that's still a 0. Like, all right, it's right, but we need to put a sensor in there. We got that sensor. We got a distance sensor. So let's go to sensing. And let's go down here to distance. Here's a distance object distance in millimeters. I bet we could change that. Yeah, sure could because it's got a down arrow. Let's put that in that little pill-shaped box. So there's the distance 12. Well, let's change our millimeters over to inches. Okay, so what we're saying now is the same thing. We're saying if the distance sensor is reading something that's within 3 inches, then you need to do this. So it's read something within 3 inches. But you know what the problem is? I have it set to color sensor. So I got to change my code. So what I goofed on here, right, is distance 12 when it should have really been distance 11. So I'll change that real quick. That was distance 11. And notice it changed. It did a nice job for me. So now I'm going to re-download that. Right here's my distance sensor. So now I've got my hand is covering that up. So now the motor's going to run. Same kind of thing every time I do that because I put it in a forever loop, right? So what we've got here is we've got a color sensor with 3 motors. Now, a couple of keys when you're dealing with the optical sensor is you really should turn the light on. It has a light on it, and that's really helpful to put in there. So we're looking at this code, and it says basically, I want to say when it detects red, spin motor 1. If it doesn't detect red, stop motor 1. If it detects green, start motor 2. If it detects blue, then start motor 3. So that's what we're going to do real quick. I'm not going to go through the entire thing, but we'll get through a lot of it here. So we'll go ahead and just start a new project here. And I got to set up, right? My strategy is, all right, this time I've got an optical sensor and I know that that rascal is at port 11, right? Okay. I'll go ahead and add motor 1. While I'm here, I can go ahead and add motor 2. And I could add motor 3 just to do it. So the first thing I do and go to control and I say, all right, this is going to all be in a forever loop because I want it to happen over and over. This looks like an if then else. Come up here, if then. So let's take a look at sensing. Say optical sensing right here. If optical 11 detects red, then, and we go up to motor, to the motion tab, and we say, well, let's Let's set our motor velocity. You don't really have to set your motor velocity every time. Okay. It's just something I have a habit of doing with the kids. And I'll just say spin motor one forward. If else, stop motor one. And we will do one more just so you can kind of see it. So then I'll say if then else. Kind of the same code. Okay, here's a shortcut. I could actually click right here and say duplicate. All I did was right click on it and say duplicate. Now I've just got to change a few things. I'll say motor two, motor two, motor two, and then instead of red, I'll say green.